Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video is going to consider matrix addition. Okay, that is, we're going to consider how to add two matrices together. Okay, given different forms of matrices. Let's just recall, that the dimension of a matrix, is defined to be a tuple. Okay, is defined to be a tuple. Okay, let's say or C. Okay, where or represents the number of rows, in the matrix. Okay, and C represents the number of columns, okay, in the matrix. Okay. So for example, okay, let's say a 2 by 1 matrix. Okay, a 2 by 1 matrix has 2 rows and 1 column. So it would look something like this: 2, 1. Okay, has 2 rows, okay, and it has 1 single column. A 3 by 1 matrix, okay, would have 3 rows and 1 column. So it would look something like this: maybe 3, 2, 4, 3 rows, and it has a single column. Okay. A 2 by 2 matrix, okay, a 2 by 2 matrix would have 2 rows and 2 columns. So it might look something like this: has 2 rows, so maybe 2, 5, and 2 columns, 7 and 8. Okay, we have 2 rows and we have 2 columns. And something like maybe a 3 by 2 matrix. Well, a 3 by 2 matrix would have 3 rows and also 2 columns. So it might look something like this: 1, 4, 7, 3, 6, 9. Okay, there you go. We have 3 rows and we have 2 columns. Okay, when it comes to the addition of matrices, okay, what is really important is that we can only add matrices together, okay, that have the same dimension. Okay, so matrix addition, okay, can only be performed on two matrices okay, that have the same dimension. Okay, that's an important point. So if I want to add two matrices together, they must have the same dimension. They must have the same number of rows and they must have the same number of columns. For example, so how do we add two matrices together? Okay, so let's look at an example. Okay, let's consider the matrices. Let's say A is equal to 2, 1. Let's say B is equal to 4, 2, 7, 1. Let's say C is the matrix, let's say 4, 7. And let's say D is the matrix, let's say 3, 5, 6, 2, 1, and 4. Okay. So what we've defined previously is that to add two matrices together, to perform matrix addition, okay, we can only perform matrix addition when the two matrices, okay, have the same dimension. Okay. So for example, we could add A and C together. So A and C, A plus C, okay, can be performed, okay, as the dimension of A is 2 by 1, okay, and the dimension, okay, of C is also 2 by 1. Okay? So that could be done. Okay? What about if we try to add A with B? Okay? So A plus B cannot be performed, okay, as the dimensions, okay, are not the same. Okay? And that's important. They are not the same. Okay? A has dimension. A is a 2 by 1 matrix, whereas B is a 2 rows and 2 columns is a 2 by 2 matrix. Okay. So it's important to be able to add two matrices together. They must have the same dimensions. We cannot add two matrices together that have different dimensions. Okay. So the result, okay, okay, of adding A plus C, okay. Well, to add two matrices together, what we do is we add similar entries. Okay. So A is 2, 1, plus C is 4, 7. So the resulting matrix is going to be a new matrix. Okay. It's a new matrix that has the same dimensions as the previous matrices. Okay. But what we do is we add like entry with like entry. Okay. So we'd add the 2 with the 4. So we get 2 plus 4. And we get 1 plus 7 to give us a new matrix that's equal to 6, 8. Okay. Which is also a 2 by 1 matrix. 2, 1 is a 2 by 1 matrix. Okay. 4, 7 is a 2 by 1 matrix, and when we add them together we end up with a 2 by 1 matrix. Okay. So from a general perspective, okay, in general, okay, given two matrices, okay, with the same dimensions, okay, let's say A is the matrix that has, let's say it's an m by n matrix. Okay, let's say it's an m by n matrix, meaning it has m rows and n columns. Okay, so the first entry would be A1, 1, indicating that this entry is on the first row, first column. The next entry would be A2, 1, indicating that this entry is on the second row, first column, and so on and so forth.